Good day, everyone. Today, I am going to present the analysis of factors influencing lecture behavior in maintaining academic integrity using the fuzzy interpretive structural modeling (FISM) methods. This study is conducted by Uki Yudhartama, IM, from Universitas Muhammadiyah Magelang, Rini Sukiyarti from Universitas Semarang, and Erwin Erlangga from Universitas Semarang. Introduction. Academic integrity is a fundamental aspect of maintaining the quality and credibility of higher education. Lectures play a crucial role in preserving academic integrity by setting an example through ethical and professional conduct. However, maintaining academic integrity has become increasingly challenging due to the pressures of globalization. Factors such as publication target, administrative demand, and other external expectations complicate the situation. Additionally, weak institutional policies exacerbate these challenges, leaving lecturers vulnerable to violation of academic integrity. In Indonesia, there have been reported cases of academic integrity violation by lecturers. The primary cause of this violation are the lack of consistent policies and insufficient awareness regarding the importance of academic integrity. Furthermore, lectures' behavior is influenced by a variety of internal and external factors, with necessitated of comprehensive understanding of this influence in order to effectively address the issue. Research contents. Previous research has shown that several factors play a crucial role in maintaining academic integrity. Among these, management support, clear policies, and continuing ethics education have been identified as key elements. Moreover, external pressures such as publication demand also significantly influence the ethical behavior of lecturers. In this context, the fuzzy interpretive structural modeling method was chosen to analyze the complex interaction between these various factors. FISM helped in compiling a hierarchy of the factors that influence lecture behavior, allowing for a deeper understanding of how they interact with one another. The findings from this research are expected to contribute to the development of higher education policies in Indonesia. The will provide an in-depth understanding of the factors affecting lecture behavior in maintaining academic integrity. Additionally, this research aims to contribute to the development of educational psychology theories and policies related to the ethical behavior and academic setting, ultimately leading to more effective policies recommendation for universities and educational institutions. A research objective, this study aims to identify and analyze the factors that influence teacher behavior in maintaining academic integrity within Indonesia universities. By employing the fuzzy interpretive structural modeling method, the research will map out the relationship and hierarchy of the factor affecting lecture behavior. Additionally, the study will provide valuable recommendation aimed at strengthening academic integrity in higher education. FISM helps to systematically explore the interplay between various factors and prioritize them based on their significance, ultimately guiding effort to enhance ethical standards within academic environment. Addition to the FISM methods, the fuzzy interpretive structural modeling (FISM) method is employed for several key reasons that enhance the effectiveness of the study. One, overcoming complexity. FISM is particularly useful in mapping the relationship between complex factors such as lecture behavior, institutional policies, and management support. It also helps in visualizing hierarchical relationship, which makes the system easier to understand. Two, handling uncertainty. FISM utilises fuzzy logic, which allow for handling uncertainty when assessing relationship between factors. This is particularly important because real-world relationships are rarely binary yes or no, and fuzzy logic offer a more nuanced view using scale and influence. Three, interactive relationship mapping. FISM help create an interactive map of relationship between factors. This approach reveals the most influential factors in the system, allowing for identification and prioritization based on their significance. Four, key factor identification. By applying FISM, we can identify key drivers that have the most significant impact on the system. We'll also recognizing factors that depend of others. This allows for better targeting of intervention. Five, data-driven decision making. The result provided by FISM offer a clear visualization of how different factors interact. This aids in making data-driven decisions, leading to more informed and effective strategies for improving academic integrity. Six, flexibility. FISM is a versatile method that can be applied to various contexts, including education. It also allows the integration of diverse data sources, such as interview and institutional policies, providing an comprehensive approach to analysis. Problem formulation. In the study, we aim to address two main questions. One, what are the factors that affect lecture behavior in maintaining academic integrity? This question seeks to identify the various factors, both internal and external, that influence how lecturers uphold academic integrity in their teaching and research activities. These factors can range from institutional policies and management support to external pressure and personal belief. Two, how can the application of the FISM method help map the interaction between factors? The second question focuses on how the quasi-interpretative structural modeling method can be used to analyze the complex relationship between these factors. By applying FISM, we aim to understand how these factors interact with each other, creating a clear map of their influence and dependency. This will allow us to better prioritize and address the key drivers that influence lecture behavior in maintaining academic integrity. Methodology. This study follow a structured methodology to explore the factor affecting lecture behavior in maintaining academic integrity. The process involved several case studies. One, literature review. The initial step in conducting a thorough literature review to gather existing research and identify factors in influencing academic integrity. This form the foundation for understanding the context of the study and help to define the scope. Survey. A survey is conducted to collect data from a large crowd of lecturer and academic staff. The survey helped in gathering insight on the various factors impacting academic integrity from broad perspective. Three, focus group discussion. To deepen our understanding, focus discussion group are organized. This discussion with selected lecturer and administrators provide qualitative insight into the factor effective behavior, allowing for a more nuanced understanding beyond the survey data. For FISM, the fuzzy interpretive structure modeling method is applied to map out the relationship and hierarchy of the identified factors. This approach helps visualize how the factors influence one another and which are most critical in shaping lecture behavior. Result, finally, the study presents the result, including a clear visualization of the relationship between the factors and a recommendation based on the analysis to improve academic integrity practice. This methodological framework ensures a comprehensive approach to understanding and addressing the factor influence academic integrity. FISM stakes, the site outline the stake involved in applying the fuzzy interpretive structure modeling method to analyze factor affecting lecture behavior in maintaining academic integrity. One, identify relevant factors. The first step in the process is to identify the key factors that influence lecture behavior. This includes recognizing both internal factors such as personal, ethic, and institutional policies, and well as external factors like societal pressure. Two, preparation of SSIM fuzzy for interfactor relationship. Next, a fuzzy structural self-interaction metric SSIM is prepared. This metric represents the relationship between the identified factors and use fuzzy values to indicate the strength of influence between them. Three, convert to fuzzy reversibility metric. The SSIM is then converted into a fuzzy reversibility metric. This metric helps to visualize the direct and indirect influence between factors, providing a clearer understanding of the relationship. For formation of levels and hierarchy of factors. After the metric is created, the next step is to form a hierarchy. This involves in determining the level of influence and organizing factor in terms of their drive and depends. 5. Preparation of FISM diagram for visualization of factor relationship. Diagrams are then created to visualize how factors interact and influence one another. These diagrams are crucial for understanding the system and prioritizing the most influential factor. 6. Analyze and interpretation of result. The result from the FISM analysis are interpreted to identify key and dependent factors. This analysis helps in understanding which factor and the primary driver and which are more dependent on others. 7. Validation and implementation of IFM analysis result. The final step is validation the analysis result and implementing them into practical recommendation. That recommendation aim to enhance academic integrity by addressing the key influences factor. Factor influencing behavior in maintaining academic integrity. The slide outline the key factors that influence lecture behavior in maintaining academic integrity. Factor one, policy and regulation. Policies implemented by academic institutions play a significant role in shaping lecture behavior. Strict policies regarding plagiarism and academic misconduct help to foster ethical behavior among lecturers. For instance, a well-defined policy can set clear expectations and guidelines to management commitment and support. The level of support from management significantly affects lecturer commitment to academic integrity. Adequate resource allocation and policy backing from management can reinforce the culture of the integrity within the institution. A study by Pamis et al. 2020 found that management support and strengthens academic integrity through both resource and policy enforcement. 3. Awareness and education. Education and ongoing training on academic ethics are essential for building lecturer awareness regarding the importance of academic integrity. It ensures that lecturers are well informed about the ethical standard expected in academia. 4. Infrastructure and technology. Technologies such as plagiarism detection software play a crucial role in supporting academic integrity. The use of technology helps in identifying unethical behavior, thus encouraging lecturers to maintain high ethical standards. According to Ghani, the integration of technology positively impact ethical behavior and academic setting. 5. Business and operational process. Transparent and efficient operational process are key to preventing breaches in academic integrity. Well-structured procedure ensure clarity and fairness in academic activities, thus minimizing opportunities for misconduct. 6. External and social pressure. External pressures from the community, accrediting bodies, and the public, and additional responsibility of lecturers to adhere to high academic ethical standards. Social and institutional aspects can significantly influence the behavior. Finance and investment. Financial support from the institution, such as funding for academic integrity development program, can directly impact lecture behavior, providing resources for ethic training and other integrity enhancing program ensure that lecturers have the necessary tools and motivation to uphold ethical standards. Fuzzy linguistic scale. The slide presents the fuzzy linguistic scale, which is used to measure the strength of influence between factors in the analysis. The scale consists of four levels, each with associated fuzzy value and notation. 1. very strong fuzzy value 0.66, 1.00, and 1.00 notation E. The represent a very strong influence between factor. Moderate fuzzy value 0.33, 0.66, and 1.00 notation S. This indicates of moderate level of influence, meaning the factor of a significant but not overwhelming effect on each other. Weak fuzzy value 0.00, 0.33, and 0.66 notation L. This represent a weak influence between factors where the connection is present but minimal. Not influence, passive value 0.00, 0.00, 0.33, notation T. This indicates that there is no significant influence between the factors. This passive value helps in capturing the uncertainty and gradation of relationship, allowing for a more nuanced analysis of how different factors interact with one another. Fuzzy classification diagram. This diagram represents the fuzzy classification of values on the fuzzy scale. The graph illustration how different fuzzy values correspond to the level of influence between factors. Yeah. T, no influence. This is represented by the red section where the fuzzy value is close to 0. It indicates no significant influence between factors with a fuzzy value range of 0.00, 0.00, 0.33. L, weak. The yellow section represents a weak influence where the fuzzy value is between 0.60 and 0.33, but still a bit more than the no influence range. This corresponds to the fuzzy value of 0.00, 0.33, 0.66. As moderate, the blue section in the middle shows moderate influence with the fuzzy value ranging from 0.33, 0.66 to fuzzy value for this category is 0.66, 0.66, 1.00. Key, very strong. The dark red section represents very strong influence with the fuzzy value ranging from 0.66 to 1.00, indicating a highly significant influence between factors. The fuzzy value for this classification is 0.66, 1.00, 1.00. This classification helps in assessing and visualizing how strongly one factor influences another, offering a clearer picture of the relationship between various elements in the study. Fuzzy SSIM. This table represents the fuzzy structural asset interaction metric, which is a key component in the FISM method. It is used to capture and represent the relationship between various factors that influence lecture behavior in maintaining academic integrity. The fuzzy values are used to indicate the strength of influence between each pair of factors. Each row and column correspond to the different factors such as policies and regulation. Yeah. F1, commitment and management support F2, and so on. The fuzzy notation suck as key very strong, S moderate, L weak, and T no influence are placed in the metric to show how strongly each factor influences the other. For instance, Formula 1 atau F1 or F1 policies and regulation has a very strong influence on F2 commitment and management support as indicated by the key in the corresponding cell. F3 awareness and education has a weak influence on F2 as shown by the L in the metric. This metric helps to build an understanding of how the factors are interconnected and which ones are more influential in shaping lecture behavior in relation to academic integrity. This slide presents fuzzy reversibility metric based on the fuzzy structure sharp interaction metric FSIM. Each cell in the metric represents the influence between two factors using fuzzy values to indicate the strength of the influence. For example, the relationship between F1 policy and regulation and F2 commitment and management support is marked with a fuzzy value of 1, 0, 0.66, 1.0, 1.0, which means a very strong influence in the fuzzy linguistic skill. The relationship between F3 awareness and education and F2 is marked with 0, 0.0, 0.33, 0.68, indicating a weak influence L in the fuzzy linguistic scale. The relationship between F7 finance and investment and F6 external and social pressure is marked with 0.33, 0.66, 1.0, which indicate a moderate influence as in the fuzzy linguistic scale. The metric help in identifying which factors have the most significant impact on others, and the fuzzy values capture the intensity of these influences. It is an essential step in understanding how different factors interact and influence lecture behavior in maintaining academic integrity. Double the fuzzy fit initial eligibility metric. This slide presents the fuzzy fit initial eligibility metric, which is a crucial step in the FISM methodology of the applying fuzzy logic and determining the fuzzy relationship between factors. The next step into the falsify dash values. This process simplifies the fuzzy values into crisp values, typically 1 indicating a strong influence or 0 indicating no influence. One means that the factor in the row has a direct significant influence on the factor in the column. 0 means there is no significant influence between the factor. For instance, F1 policy and regulation influence F2 commitment and management support with a value of 1 showing a strong relationship between these two factors. F3 awareness and education does not have a significant influence on F5 business process and operation as indicated by a 0 in corresponding cell. This metric is important because it helps us visualize the relationship between factors and identify which factors are key influences in the model. It aids in building the next step of the analysis, including the formation of factor levels and hierarchy. Hierarchical diagram of factor influencing academic integrity. The hierarchical diagram of factor influencing academic integrity illustrates the hierarchical structure of various factors that impact academic integrity. This diagram visualizes the flow of influence and the relationship between factors in an academic context. Diagram structure explanation. Top level F6 strategic factor. F6 is positioned at the top, acting as the primary driving factor that influences other elements. This factor typically represent strategic factor such as national policies, external pressure, or institutional strategic direction guiding academic integrity over middle level. F F7 and F1 supporting factors. F7 and F1 are at the middle level, representing institutional support. F7 such as organizational culture or supporting infrastructure, and individual factors such as personal commitment or academic honesty. Lower middle level, F2 operational factor. F2 acts as a central link that receives influence from the top level and distributes in the two lower levels. This factor is generally associated with operational mechanisms such as daily governance or policy implementation. Bottom level, F3, F4, and F5 implementation factor. F3, F4, and F5 are at the implementation level and are directly influenced by the layers above. F3 reflects the work environment such as physical or psychological conditions in the workplace. F4 relates to professionals' development such as training or workshop to enhance competence. F5 focus on social interaction or community such as collaboration between lecturer and student. Flow of influence. The strategic factor F6 influence the supporting level F7 and F1, which subsequently impact the operational factor F2. Finally, the operational factor distributes its effect on the implementation level F3, F4, and F5. The connecting lines illustrate the dynamic relationship between these factors. Meaning of the diagram, this diagram emphasizes that academic integrity is the result of a combination of various factors ranging from high-level strategy to on-the-ground implementation. By improving the strategic factor F6, positive impact can be felt throughout all levels, including implementation. A micmac diagram with quadrant. This is the micmac matrix, the impact, cross multiplication, and classment diagram, which help classify the factor influencing academic integrity into four quadrants: driving factor, linkage factor, dependent factor, and autonomous factor. Driving factor, quadrant 1, factor in this quadrant have high driver power and low dependence power. The significantly influence other factor but are not influenced much themselves. In this case, F7 finance and investment is located in this quadrant, showing that it has a strong influence on other factors but is less influenced by them. Linked factor quadrant 3, these factors are in the middle, meaning they have both a moderate level of dependence and influence, have two commitment and management support, is in this quadrant, highlighting its key role in both influencing and being influenced by other factors. Dependent factor, quadrant 2 factor in this quadrant have high dependent power and low drive power. They are largely influenced by other factors but do not significantly affect other factors themselves. F3, awareness and education, and F5, business process and operation, are examples of factors placed here. Autonomous factor, quadrant 4, these factors have both low drive power and low dependence power, meaning they do not have a significant influence on other and are not significantly influenced by other factors. This category is not populated in this diagram. The dependence threshold and drift threshold and help identify which factor belong to each quadrant, allowing for a clear understanding of their roles in the system and the interplay between them. Conclusion. The study used the fuzzy interpretive structural modeling method to analyze the factors that influence lecturer behavior in maintaining academic integrity. The key finding can be summarized as follows. One, factor influence, 7 main factors were identified, including policy and regulation, management, commitment and support, awareness and education, infrastructure and technology, business and operation process, external and social pressure, finance and investment. A power driving factor, F6 and F7 are placed at the top of the hierarchy. These factors have a strong influence on the overall system but are less affected by other factors. F1, policy and regulation, also plays a crucial role setting the foundation for ethical behavior and guiding the other factors. Prioritizing of driving factor, the driving factor quadrant 4, such as F6 and F7, should be given priority as the exhibit high driver power but minimally influences by other. F2, management, commitment, and support, which belong to the connecting quadrant 3, plays a vital role in integrating the other factor and creating synergy. For visualization and fit diagram, the mimic diagram effectively visualizes the priority of factor by mapping drive power and dependence power, helping to identify which factor should be prioritized for intervention. The hierarchical diagram show the relationship between factors in a structure and clear manner, aiding in understanding their interaction. 5 supportive factor like F3, awareness and education, and F4, infrastructure and technology, support the system, but have a lower direct influence on other. The factors help strengthen the integrated system in more indirect ways. In conclusion, the study highlights the importance of focusing on high-impact driving factors such as external pressure and finance, while also ensuring proper support and integration through factors like management support and awareness to maintain academic integrity in higher education. suggestion. The study presents several suggestions to strengthen academic integrity among lecturers using the result derived from the ISM analysis. This recommendation are focused on prioritizing critical factor, managing connecting between factor, and optimizing supporting factor. The key suggestions are prioritize prioritize driving factor, external and social pressure. F6, it is recommended to increase collaboration with accreditation bodies and the wider community to establish and uphold integrity standard across institutions. Finance and investment F7 allocate sufficient initial resource to support critical activities, including training program, the acquisition of technology and the implementation of policy frameworks aimed at enhancing academic integrity. To manage connecting factor, management, commitment, and support F2, it is essential to secure for commitment, full commitment and support from constitutional management. This can be achieved by ensuring adequate policies, providing necessary resources, and maintaining continuous oversight to support academic integrity initiatives. Optimize supporting factor, awareness and education F3, strengthen effort related to training program and awareness campaign, focus and academic ethics. This can be done through seminar, workshop, and incorporation ethic education into curriculum. And infrastructure and technology F4, investment in technological infrastructure such as plagiarism detection software and other academic tools should be enhanced to support and monitor academic integrity effectively. For evaluation and refinement, jadi regular evaluation of policies and driving factors should be conducted to assess their effectiveness in influencing lecture behavior and maintaining academic integrity. Use survey and feedback mechanism to measure the effectiveness of the implemented change, ensuring their element with the goal of improving academic integrity. Implementation strategy, introduce more assertive policy F1. I'm at fortifying the academic integrity system across university. The result from this analyzing as a strategic guide for long-term planning and decision-making to strengthen the overall framework for maintaining integrity in higher education. The step aim to create a sustainable academic environment where integrity is a fundamental component supported by robust policies, management, and technology infrastructure. Thank you for attention. We appreciate your interest in this research and in the insight share throughout this presentation. If you have any question or would like further clarification on any aspect of the study, please feel free to ask. Your feedback and question are highly valued. Thank you again for your time and participation.